Hello students, in this video we are going to learn how to find principal amplitude of a given complex number. This is very important topic. So in previous video, as I said, principal amplitude of Z is always lies in between minus pi to pi. This is the important thing we have to remember. It ranges from minus pi to pi only. Okay, so that is the reason why I have drawn diagram with the boundaries minus pi to pi. Like this is the initial line treated as 0 degrees, 0 from here to here pi by 2, from here to here more pi by 2 means pi line. So again in this direction, in clockwise direction, if you move from here to here pi by 2, but clockwise direction treated as negative angle, that's why minus pi by 2. More minus pi by 2 means minus pi. So this line acts as both pi line as well as minus pi line. Okay. Now moving on to principal amplitude of Z. So principal amplitude of a complex number depends on the position of Z. Okay, where Z is located in Argand plane. So if you take this plane, we have 4 quadrants. There is a possibility to lie P in one of the 4 quadrants. Suppose Z is equals to A comma B, A comma B. So how can we identify the position of Z? So by using the signs of coordinates, x coordinate, y coordinate signs tell you the story. So here x coordinate positive, y coordinate positive. So both x and y coordinates positive. So those kind of points belongs to first quadrant. So if Z belongs to Q1, then your arg Z, principal amplitude of Z lies in between 0 to pi by 2. You see first quadrant, 0 to pi by 2. So always arg Z lies in between 0 to pi by 2. Now moving on to second quadrant, if Z equals to minus A plus iota B or minus A comma B, what happened here? X negative, y positive. X negative, y positive. Obviously that is second quadrant. So if the given complex number is in second quadrant, its principal amplitude always lies in between 90 and 180. Borders you see, 90 to 180. Similarly, if Z is in the form of minus A comma minus B, what happened here? Both the coordinates negatives, x negative, y negative, which can happen in third quadrant. Okay, in third quadrant, x negative, y negative. Suppose if the given complex number is in such form, arc Z, principal amplitude of Z always lies in between minus pi to minus pi by 2. Okay, these are the borders, minus pi to minus pi by 2. Suppose if the given complex number is in fourth quadrant, how to know? A comma minus B means x positive, y negative. X positive, y negative. That is the fourth quadrant. If Z belongs to Q4, your arg Z lies in between minus pi by 2 to 0. You see borders, minus pi by 2 to 0. So just this information gives you the range of arg Z. Depending on the position of Z, how arg Z lies in between. Okay, but if you want to know exact value of principal amplitude of Z, we have some formulas. Okay, so let us see how we get formula. So let us take the given point in first quadrant, P of x comma y. Now the line joining these 2 points is the modulus line. Now the angle between modulus line and the real axis, so in anti-clockwise direction, is nothing but your amplitude of Z. So if P belongs to, P is nothing but point represented by complex number Z. Okay, so if P belongs to Q1, it's very easy to find its argument because it's an acute angle, an angle between 0 to pi by 2. We are going to get RZ in between 0 to pi by 2. So let us see how to find theta. For that you need to construct a right angle triangle. So how to construct? Let PM be the perpendicular drawn from P to real axis. So that triangle OPM formed in a right angle triangle. So in this right angle triangle, if you use formula tan theta, opposite side by adjacent side. Tan theta is equals to y by x. From this theta is equals to tan inverse of y by x. But to make theta in between 0 to pi by 2, theta positive, so you have to keep, okay, tan theta must be positive. In first quadrant, tan theta must be positive. That's why let's keep modulus of y by x. So theta is equals to tan inverse of mod y by x. This is the formula we need to use if the given complex number belongs to Q1. Similarly, now with the help of this one, we can find the remaining complex numbers. Okay, if the complex number belongs to the remaining quadrants, this can be used. This acute angle concept can be used. If Z belongs to Q2, as I said, your RZ lies in between pi by 2 and pi, means either more than pi by 2 or less than pi. Pi by 2 plus something or pi minus something. Okay, so there are two ways to go in between pi by 2 and pi. One is pi by 2 plus something or pi minus something. So here pi minus something is preferable. Pi is preferable because in case of pi, no trigonometric ratio changes. In case of pi by 2, trigonometric ratio changes concept. So that's why pi minus theta, pi minus something. But something is nothing but your theta always. Okay, pi minus tan inverse of mod y by x. So if Z belongs to Q3, if Z belongs to Q3, your RZ must come in between minus pi to minus pi by 2. That means either more than minus pi or less than minus pi by 2. Either minus pi plus something. To get more, we have to add something. To get less, we have to subtract something. Minus pi plus something or minus pi by 2 minus something. I don't want to use minus pi by 2 concept. So I'll go with minus pi plus something. Minus pi plus, what is that something I said always? Tan inverse of mod y by x. Next. So if Z belongs to Q4, if the given complex number is in fourth quadrant, so your RZ must lie in between minus pi by 2 to 0. So how can I get between value minus pi by 2 to 0? So there are two ways I said, minus pi by 2 plus something or 0 minus something. So I don't want to prefer minus pi by 2 plus something. In case of pi by 2, function changes takes place. That's why I don't prefer this one. So 0 minus something. 0 minus, what is that something? Tan inverse of mod y by x always. Okay. Just this diagram shifts like this. Second quadrant, third quadrant, fourth quadrant. That's why I used the resultant of this diagram. In every case I used the resultant of this diagram with rules and regulations. So that angle brought into the required range. Suppose if you take these examples, if you want to find the principal amplitude of 1 plus iota root 3, here 1 comma root 3 belongs to Q1. Both the coordinates are positive, na? Q1. So that's why use this formula. Theta is equals to tan inverse of mod y by x, mod root 3 by 1. So tan inverse of mod root 3 is what? Root 3 tan 60. So tan cancels, so 60 degrees or pi by 3 radians. Next, moving on to this one, here minus 1 comma root 3, x is minus 1, y is root 3. So x negative, okay, minus a comma b form, na? x negative, y positive belongs to Q2. Q2. In Q2, RBZ formula we have to use pi minus tan inverse of mod y by x. Already we found tan inverse of mod y by x as pi by 3. Now pi minus pi by 3. So answer 2 pi by 3 is the principal amplitude for this complex number. Now here minus 1 comma minus root 3. Both the coordinates are negative, which can happen in third quadrant. Na? So in third quadrant we have to use this formula, minus pi plus this one. This result we got here now, same result we can use. So minus 3 pi plus pi. So minus 2 pi by 3 will be the principal amplitude for this complex number. If you go for this one, 1 comma minus root 3, x positive, y negative, which can happen in fourth quadrant. So in fourth quadrant, I told you to use this formula, minus tan inverse of mod y by x means pi by 3. Na? So minus pi by 3 is the answer. So in this way, we can find the principal amplitude of any complex number. Okay.